Okay, so yesterday we went through and did the even problems. Today we're going to do the odd problems. Number one is true. The mean is the measure of central tendency most likely to be affected by an outlier. An outlier will move the mean either greater or lower than, and it is the one that's going to be most likely affected. Remember, the mode is going to be the number that's repeated the most, and the median will be the number in the middle. And so those could either way be affected sometime in some cases, but most of the time they will not. Number three, a data set can have the same mean, median, and mode. That is true. An example of that would be 1, 1, 1. If we have a data set that's all ones, then it would have the same mean, median, and mode. Number five, mean, median, and mode are the same. An example of that would be 1, 2, 2, and 3. Your median would be 2, your mode would be 2 because they repeat. Number 7, mean is not representative of a typical number in the data set. That is false. Oh, that's not a true-false question. We need to come up with an example where it would not be true. And so let's say that we had 5 ones and then we had 1 billion. If we found the mean would be in the either millions, probably in the millions, or tens of millions. So that is not representative of the typical number in the data set. Typical number in the data set would be a 1. All right, number 9. This is skewed right. It's skewed right because the tail number, or the number that numbers that drift off, is on the right-hand side. Number 11 would be uniform. They're all about the same. It doesn't have to be perfectly the same, but it's close enough. Actually, with uniform, let me check on that. No, I was right. Always trust your first instincts. Uniform, it's as long as it's close, it's good. Number 13, the frequency distribution of 180 rules of a dodecagon. Which would this be? If you look at it, it would be number 11. Dodecagon has 12 sides, so you have your bottom numbers 1 through 12, and then you would predict them to be about the same number of rules, not perfect. Number 15, frequency distribution of scores on a 90-point test where a few students scored much lower than the majority of the students. That would be number 12. Majority of the students scored higher, like 72 to 100, and then you had a few students that scored lower. All right. So that was 15. Number 17. We put this all into the calculator. Your mean is going to be 14.8. Your median is going to be 15, and your mode is going to be 16. 16 is the number that repeats the most. There's 4 of those. Number 19. Your mean would be 1,178.4. Your median would be 1,229, and your mode would be none. Number 21. We would have your mean being 43.07. Your median would be 44, and your mode would be 44. Number 23, your mean is 30.1, median is 31, and this is bimodal. It has a mode of 31 and 34. Number 25, your mean is 16.6, your median is 15, and your mode is none. None of the numbers repeat. Remember, you are allowed to have no mode. Number 27. The responses of a sample of 1,000 adults who were asked what type of collected lenses they wore are shown in the table at the left. Now, I want to discuss number 28 as well yesterday. I don't know what I was thinking. You can only have a mode on these types of questions. There's no mean or median. Okay, so our mode would be eyeglasses as for number 27, no mean and no median. The reason is it's nominal data and you're just looking at the frequency. You can't have like, oh, well, the mean would be 350, so it would be either none or eyeglasses. It's not the way it works. With that being said, number 28, all that you can find on this one is a mode, which would be money needed 326. Number 29, once again, you can only find the mode. So the mode of this one would be juniors, and that's it. Number 31, here we need to find the mean, median, and mode for it. Remember that on this chart, the 0 means the leading number, and then it's the second number, so this would be 6, 7, 12, 15, 18, 19, 20, 24, 24, 24. Speaking of modes, 24 and 35 are our modes because they each have 3. Your mean for this would be 29.8, and your median would be 32. Number 33, again, you're just going to follow the dots. So you have a dot at 5, a dot at 8, so on and so forth. X bar would be, or your mean would be 18.9. Your median would be 18.5. Mode is 15. And you can tell just by looking at it what your mode would be. Your mode is the highest dot, or the one with the highest dots. All right, number 35. Sick days used by employees. So A is going to be your mode because it's the highest bar. Your median would be B, and C would be your mean. This goes much better when I do the exercises beforehand. Just saying. Number 37. Determine which measure of central tendency best represents the graphical data. If you look at this, the majority of number 37 comes in the always category. And so always would be the number, or would be the data that best represents. And which measure of central tendency would that be? That would be the mode. Number 39. Which would be the best. Generally, if you see it as a graph where the middle is the highest like that, and the other two sides are basically symmetrical, so about the same on either side of the middle, then your mean is going to be your best measure of central tendency. Number 41. So here we had to find a weighted mean. I'll go just through the procedure of that without actually having to do the calculations. In order to do this, you have to first multiply your score by the percent represented as a decimal. So 85 times 0.05 plus 80 times 0.35 plus 100 times 0.2 plus 90 times 0.15 plus 93 times 0.25. Okay, when you multiply those out and add them all up, you get 89. Now, a lot of times it's going to have you divide by 100, but in this case, all these were in percentages anyways. So anytime it does that, you're going to end up with what your percentage actually is. So it'd be 89%. Number 43. Now this is an example of where we're going to have to divide before we're done here. What you do is you take the 523 times 24 plus 2415 times 2 plus 250 times 4. And now you divide by the total, which is 30. And so whenever you do that, you get number 46, 1273. $612.73. Okay, number 45. Fix this up. Number 45, student receives the grade shown below with an A worth 4 points, B worth 3 points, C worth 2 points, and D worth 1 point. Then, if it's an A in a 4-credit class, that means that you take the 4 and you multiply it by 4. Then for B, it's 3 in 2 3-credit classes, so that would be 6 credits worth, plus a C, which is a 2 in 1 3-credit class, and a D, which is a 2 in 1 2-credit class. So that would be a 2 credit. Okay, now we divide by the total number of credits. That would be 10, 13, and 15 credits. When you do that actual division, you get 2 right on the nose. All right. Turns out I just didn't finish writing this answer out. This is 2.93. Because it's 44 divided by 15. So that would be your answer, 2.93. That would be your grade point average. All right, for number, let's see, that was 45. 47, in exercise 41, error was made in grading your final exam. Instead of getting 93, you scored 85. What is your new weighted mean? So the only thing that would change is that final exam score. And so you would do it exactly the same, except you would change that number and still average it out over 50. Or sorry, we weren't dividing by 15. That was the other question. We were dividing by 100, so you just leave it the same. That would be 87. So it'd be an 87 instead of an 89. Number 49. The fuel economy for highway mileage. Approximate the mean of the frequency distribution. So here you would find the midpoint of each class. So we do 33 plus 29, divide that by 2. So you give you 31, and you would do 31 times 11. Then you would find the middle of 34 and 38. So you give you 36, multiply that by 12. Then midpoint of 39 to 43, which would be 41. 41 times 2. Then you would do 46 times 5. Then you would divide that by 20 or 30, because there's 30 small cars, and that would give you what your mileage was on average, which would be 36.2. Number 51, same thing here. You find the average. First one would be 4.5, then 14.5, then 24.5, going the whole way down. And you multiply each of those averages by the frequency, or the midpoint of each class by the frequency, and then you divide by the total. That is going to give you 32.2. Number 53. The easiest way to do this one is to set up your table. You're going to find your classes. So because there's 5 classes, and you take the highest number, $297, and you subtract the lowest number, which is $127. Divide that by 5. It's going to give you classes that are $127 to $161, $162 to $196, $197 to $231, $232 to $266, and $267 to $301. Then you do your frequency within each class, which would be 9, 8, 3, 3, 1. To figure out what your frequency is, you would just figure out what numbers fall within it. So 149 falls between 127 and 161. Fairly easy for that. Then you got to find your midpoint of each class. It should be 144, 179, 214, 249, and 284. You find each one of those just by taking 161 plus 127 divided by 2. Now you take each one of these, and we're going to graph it based off of that. And so when we create our histogram, it's going to be 144, and then you have a bar that goes up to 9. Then you do 179. And it's a bar that goes up to 8. Then 147, or 214. And it's a bar that goes up to 3. And 232, or 249. And that's 3. And I'm upset that I didn't make it to the end. But your last one would just be 1 for 284. Pretty easy. Not too bad at all. Except that I can't find my cursor. Okay, 55. Same thing. You're going to do 74, which I believe is your highest, or 76 is your highest. Take that, subtract the lowest, which is 62, and then you divide by 5. It'll give you classes from 62 to 64, 65 to 67, 68 to 70, 71 to 73, 74 to 76. And your frequency for each one would be 3, 7, 9, 8, 3. And your midpoints would be 63, 66, 69, 72, and 75. Then you just do a histogram based off of that. All right, during a quality assurance check, the actual coffee contents in ounces of 6 jars of instant coffee were recorded as 6.03, 5.59, 6.4, 6.0, 5.99, and 6.02. Take those values, you find the mean and the median. The mean of the first one, part A, would be 6.005, and the median would be 6.01. Then the third value was incorrectly measured and is actually 6.04. Find the mean and the median of the coffee content again. The median would stay exactly the same. It would be 6.01. And the mean would be 5.9405. Which measure of central tendency, the mean or the median, was affected more by the data entry error? It was the mean, because the median stayed exactly the same. Number 59. Identify any clusters, gaps, or outliers. If we look at this, the data would be clustered from 16 and 21. Also cluster at 36. And then an outlier, there really isn't one here. Look at number 60, there's definitely one there. The electric vehicle would be the outlier. Number 61, writing. Nobody wants to write. But consider the data set given in exercise 59. Which of the options below do you think is better for representing the data? Explain your reason. Reporting the mean of all the vehicles, or treating cars as one data set, treating trucks, vans, and SUVs as the second data set, and reporting the mean of each data set. Option 2 would actually be the better one. The reason for that is those are going to have especially high gas or especially low gas mileage, and so it's going to completely change the way that we have it. And so your trucks, vans, and SUVs are all going to be on the low side, and then your cars are on the high side. And so we could more effectively show this model if they were separated out. Number 63, consumer testing service obtained the mileages in miles per gallon shown in the table at the left, and 5 test runs performed with 3 types of compact cars. The manufacturer of car A wants to advertise that its car performed best in this test. Which measure of central tendency, mean, median, or mode should be used for each claim, or for its claim? Explain your reasoning. So you would find the mean, median, and mode of this. Your median is going to be 30. Sorry. Looking at this table messes me up. It would be 30. Your median, or your mode, would be 28. And your mean is 30.4. So knowing all that data, which would be the best way to do this? It would just be to pick whichever one is the highest for the gas mileage, which in this case would be your mean, which is 30.4. So when you enter those all in, you find that your mean is 49.23, and your median is going to be 46.5. And draw a stem and leaf plot. I think you know how to do that. You're going to do the 1, then the long line, and then 2, 3, 4, 5, 6, 7, and 8. My bad. Then you do whatever number comes after it. So like 11 would be 1/1. Then you put the 3 after that for 13. Then you're going to describe the shape of the distribution when you're done with that. That's based off your stem and leaf plot. How does it fall? Does the most of the data fall in the middle? Does most fall at the beginning? And does most fall at the end? In this case, most is going to fall in the middle. It's going to look pretty close to symmetrical. All right, that's it for that. Tomorrow we start the new section. You only have one more section in this chapter before you have a chapter test. So start to get ready for it. All right, guys.